Um, hi everyone. Yeah, I think I'm audible. And yeah, today is 14th Feb, and it's around 3:10 in the AM. I sleep late, badminton match, and I took a shower, so I'm super fresh. Um, yeah, why not to do live, right? Because it's a Valentine's Day, and let's do something productive. Uh, Let me share my screen. I'll quickly start with the video title and stuff. Like this. So the today topic is you can see the title of this. It's like Kafka and disk. Let's start with this, and we'll also see the biggest question: why Kafka is fast. Uh, so it's like many things are fast, right? Like why? What's so special in the Kafka being fast? Because um, Kafka is fast and it's special because Kafka uses disk to store events or logs. Again, I think in my previous stream I mentioned that I'll be um, I'll be telling that event and log. I will be using the term logs more than events because that's ideally the technical term. That's what the book I read, which is in that it's followed in that. So let's see, right? First, before that, we'll see Kafka clusters. So as I earlier told, a cluster is group of brokers. Yeah, and I don't know. I didn't write this. I think I was pressing tab and it gave automatically. Broker is a server that stores events or logs. Partition. Okay. No need to be good partitions. Broker is a server that stores events or logs. This is wrong. Broker doesn't store events or logs. Broker is a server that does the work of storing logs or events. As I told, cluster is a group of brokers. Now you can ask me how many brokers should I have. Uh, Even I have no idea how many brokers you can have, but having a single broker is a single point of failure, right? Because anything might happen, and you need multiple brokers. It's not like you need multiple brokers, but having a cluster with simple configurations like zero replica and no like single broker will be good for POCs, proof of concepts. But when you're developing a real-time applications, you'll be needed more brokers. Even I have no idea why do we need actually more brokers. I think I'll read it further in the book, but as of now I just read that it's mentioned in the book that you need more brokers because you gonna work with production, right? Yeah. So there are some settings there are some settings that you need to configure while creating a cluster. One is apart from that partition thing, let's only go to brokers and stuff like that into the hardware part mostly. Partitions are like logical terms, but let's not go to that. Let's go to the broker part. So what you can create is this is the one of the setting zookeeper dot path, if I'm not wrong. Um, so so it's not like zoo, it's path where zookeeper is running. That's also fine, but what actually stores in zookeeper? Metadata regarding each broker is metadata of regarding cluster, and each broker is stored in Zookeeper. Um, the second one is broker.id. So let's say there are multiple brokers. Let's say there are three brokers, and you need to give a unique identifier to each broker. So it's like when you try to create a broker with a repeated value 011, it says while creating the third broker, which ID one, which is already created, it throws an error. You cannot create that. Um, the setting, actually, to be frank, I forgot one setting, but let me explain conceptually, right? I think settings you can get easily from LLMs. So let's see the concept behind that. So two things. First one, Kafka doesn't directly write logs into disk. Yeah, obviously, because Kafka is the software and the disk is the hardware, and between software and hardware, there should be some operating system kind of thing and a kernel that helps the operating system to make the things allocate CPU, RAM, disk, and then whatever you can do that. So Kafka doesn't directly write logs into disk. Second thing is um, but ultimately logs has to sit in disk. This is the second point, which is almost equal to first point. But yeah, I'll tell you what's the why it's like two things. The first one, but how but how does Kafka writes logs into disk if it is not directly writing? So when a producer, okay, I think some spelling mistakes. When a producer is produce an event, when a producer, there won't be any. Sorry, my grammar bad. When a producer produces an event, um, the request will come and sit. So the request will come and sit in a buffer, which is in RAM. So let's say you have a um, let me quickly open Excel draw and let me draw something, right. Yeah, so let us draw here, right. So if there is a RAM here, there are different parts in RAM, right. In fact, your OS lies here. Second thing what lies here is a buffer which Kafka creates. I exactly don't know the actual name of buffer, but you can think something like the requests when. So imagine this. So producer is producing at some thousands of events per second or something like that, because there will be multiple producers. You cannot RAM cannot at a time, RAM cannot process all, CPU cannot process all 30 things, right. So instead, what it does is, before processing the event, it keeps something like a waiting list. So if there are 100 here, I'll add something. So if there are 100 logs here, now CPU might be executing one event to store, but remaining 99 will be waiting here, and which is in the request will come and sit in a buffer, which is in RAM. So you can ask if producer produces message, produces logs which are more than buffer size. What happens? Answer is simple. So if producer is sending 1,000 logs per second and buffer size is only 100, prod I can type 1,000 LPS. Yeah. If producer is sending 1,000 logs per second and the buffer size is 100, in order to, you cannot accumulate R100 in R1000 in 100, right? So um, what happens is this gets done, like remaining 900 events will be lost, and in this case you have to keep sending. Producer should keep track of what events are lost, and it has to keep sending those logs, which is which makes the system slow ultimately. So yeah, what they usually do is, I think, they increase the buffer capacity of this based on what is your production size, and this is also one of the setting. Um, how much should be the size of your buffer? It should be same as the what is the producing rate of your producer. That is one of the thing. Second one. So what exactly mean? Okay, let's say there is an event here. Let it be like this. So let's say that is buffer, and this is where actual request is there, log. So now what happens is the kernel, Linux kernel, will decide. Uh, the Linux kernel or whatever kernel, whatever the OS is, the kernel of that OS will pick this up, will pick this process or the thing that has to get executed, which is a process, and it will ask a Kafka broker. It will assign to a Kafka broker. It's like what to do with this, what to do with the log. So what it does is, what Kafka broker does is, Kafka broker doesn't directly write this into the disk. Instead, let me no, my bad. Let me decrease size like this. There's a Linux kernel, and this is a Kafka broker, and this is a disk. This is a Linux kernel, this is a Kafka, and this is a disk. Um, when log is about to get executed, the event has to be stored. Linux kernel will tell Kafka, like, dude, there is a process which is waiting, so please go and do the stuff. This Kafka application doesn't take the log and store it in the disk. What instead it does is, because it's slow, this is slow, right? Whatever is happening, this is software and hardware, and when you're trying to access direct hardware and when you're operating with hardware, this is slow. Like, disks are very slow. What rather it does is, it takes the event, Kafka takes the event, and it writes that event into a page called as page cache, which will be again in RAM, which is already in RAM, because whatever you write into RAM, it's there is a concept called of pages. You'll be writing in events to a page like this. So after a point, this page cache space will be full, right? Because like how you cannot have unlimited RAM. RAM is very small compared to disk. Maybe here in in the size here it's more, and this disk is small. But in actual real world, RAM is usually very smaller than disk. That's because of the RAM is very costly. You can think like maybe your MacBook or your laptop has 32 GB RAM, then your laptop is hell of costly. Yeah, coming to this, and Linux kernel will be running a background job. background job whose 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 duty is to see if this page cache is full or not, to see if this page cache is full or not. um, and again, obviously, if your producer is producing 1000 logs per second and your buffer is also 1000 logs, this will be getting accumulated, and these logs, Kafka push this into this after processing or whatever, maybe compression or whatever it does to this. I think producer already does compression in sense, but yeah, it's the logs will be residing in page cache, and this size also is very limited, right? And the more number of logs might exceed this, and here also will have data loss. So what this does is Linux kernel, this background job will be running, and you have a setting. I don't remember the exact setting, but I have here. Um, yeah, vm.dirty ratio. What exact spelling? Dirty underscore ratio. vm.dirty ratio. So what is this does? Um, so usually what happens is there is some default value after which this background job tells to Linux kernel ki dude, the page cache limit has been done. Now please um, take this page and store it in the disk. Linux, the kernel has another job, or I think so. I'm not sure, but the Kafka actually doesn't store this in disk, right? Because Kafka is busy serving this producer. Kafka should not be held by processing this or storing it in the disk. Instead, kernel will pick up this contents of this page cache, and it starts writing into disk. It starts flushing into disks. So when you set this 80%, so usually you understand, right? So this page cache, when I say 10%, say it's say to 10%, every time every time page cache is 10% full, then kernel will start flushing the contents of this page cache to disk, which again slows down the system. So here the entire thing, the beauty of Linux or whatever it is, or kernel and the background job is to make this entire the interactions to the disk or hardware should be lesser. That in that way we can save a lot of time. If you keep 10%, whenever this is 10% full, I think 10% will be this much. Whenever this is 10% full, um, this the kernel will take this contents of this page cache and start appending or writing into the disk, which is slow. Again, after very less time, again this 10 second, this 10% will meet. Again, you have to write, keep writing. Instead, Kafka itself can write to disk if things happen that frequently. So usually, it's suggested to put suggested to the give percent higher, like 60 to 80%. And again, this percentage is also depending on, you should know your incoming data, right? Yeah, you should know your incoming data, and based on that you can use. In this case, whenever the page cache's content is full, then only kernel will go and save the data. Till then, logs can come and sit. Linux can say process all these product producer logs, and will be keep appending to page cache. The kernel will picking up from this, and it goes to this. So let me draw a line. My bad. This and this, and again is this, and this goes till here. So this is the entire flow, right? It's not background job, to be frank. It should come from this. Yeah, and I can correct this too. And I can remove this. And I can. Let's not worry about that much about design. Right? I think you understand the flow. Kafka will be busy in serving the producer, and the Linux kernel will be actively doing the job of this pushing the contents of page cache to the disk. This is one of the where we are achieving speed, right? This is where we are achieving speed. Now, how one more way where you can you there is one more chance. There is one more chance where things get slowed down. Here, instead of telling that directly, let me tell how disk works. Disk also has files, blocks, and each block has files. Or I don't know. Is this way or other way? Let's confirm. We'll go to our account. Let's go to AI mode. Is this correct or it's other way around? Okay. Disk, D drive or whatever, blocks, then files. Okay. Okay. I am wrong. Disk also has blocks and each block as well. Actually, I'm correct. Yeah, disk also has blocks. Yeah, I'm correct. Yeah. Now, what happens by default? When kernel writes a piece of data into a file, it appends, or you can tell modifies. It appends or modifies the timestamp. Now imagine the kernel is writing 100 things, and for each write operation, you are going and saying, okay, for this operation one, this time change, for the operation two, this time change, which is again slower, right? This is slow. So there is one setting, and I'm not actually really sure what is that. I don't really remember what is that setting is. But if you do that setting, uh, you are telling you're instructing kernel to like say, dude, I'm now writing a heavy write operations. So whenever you are writing into a page, please don't update last updated timestamp, because that's slow again. You're writing a piece of thing into again the file, which is very hectic operation, because you're already writing the content of data into file, and why you want to write again at a timestamp that frequently. Yeah. So let's say if per one event, imagine kernel is doing this. Okay, so there is a per one event. Uh, Kernel writes log on timestamp. Per thousand events, kernel writes 1,000 logs on 1,000 timestamp. This is slow process. So what does Kafka do? We don't want. We already have this. And yeah, there is one more point of like this is when I say this blocks and files. The file systems comes into picture, and you should pick a very good fault less tolerant file system um, with the disk that has the disk in it. And even did I miss something important? Okay, this I told network is a bottleneck. Correct. We also increase the size of waiting room because more requests can come and sit here. Background space, okay. This also item. How many brokers settle Kafka cluster settle? I read a very good point here that I wanted to. Okay, now that you know that this is the flow, the hardware and software, the stuff where why Kafka is speed because of one reason. It's the Kafka is not directly interacting with the disk. The Kafka is interacting with the producer, and the Linux is taking care of the contents of logs writing into the disk, which is usually faster. Reason number one. Why Kafka is speed? Because Kafka dealing with only producer. Kernel is handling writing logs into disk. Second one, while kernel is writing logs, we kind of instruct kernel to not update the timestamp for every write because that's a slow process. These are the two things that makes Kafka more faster and speeder. And yeah, these are not only the two things, but these are the two things from the hardware perspective. That is why detailing to the core matters a lot because yeah, everything is every choice should pay back in such a good project. In case of a good projects. So now let's see in into flow. Into and flow of Kafka. I don't know. I also asked the same thing to me and it gives something like this. Let's see directly this instead of me telling something. Let's see like this. So the first one, producer to network. The producer that you have written converts an object into bytes, and that's because in a single batch, a producer can produce messages to the Kafka. uh, that batch, let's say 10 messages or whatever, is sent over the network to the broker that I told. And what Kafka does is the Kafka, when I means the Kafka is doing that, it means it's a broker, right? Because a server. The broker take that request, and usually first it is kept in the buffer, and when from the buffer, when Kafka picks it, Kafka places in page cache, like that. So this again buffer and stuff. And the second one, the handover network to RAM. I told you right, the kernel doesn't go to the disk; it writes into RAM and something like that. Okay, there is a point of called as dirty pages. So what is dirty page actually? The content of this page cache, number of pages in this page cache is called dirty pages because this data is yet to be written onto the disk and not yet written. That's why it's called as dirty cache. Yeah, why this is fast? Because um, the Kafka putting things in page cache, which is RAM, is 10 times faster than Kafka putting directly into disk. Why to put that headache? I think this arrow is wrong route. I think something is wrong. Okay. Okay. I think it should be the other way around. Let me figure it out. So okay, Hara should be here. Yeah. Yeah. Let me take her here. Kafka take this, and Kafka places it in page cache. That also we can draw. Kafka writes it to page cache. The Linux kernel and also takes this arrow should be here. How to delete this? Bapre. Okay. How to delete this? Data Linux will take this and Linux only write this to disk. How can we add this? I'm least bothered about diagrams, and I'm doing it because people should get clarity. Whoever watching my videos. Yeah, now it looks perfect for me. Let me delete this line. Yeah, now it looks perfect for me. And this flush and stuff I told you, right? This no time is nothing but uh, one of the setting that you put to not write that updated timestamp. The updated timestamp. Yeah. You have one more doubt. Okay, let's no need to point this. So you're telling that just when my logs are already sitting in here in page cache and it's RAM, what if this fails? What if maybe power cut happened and this is a volatile in nature, RAM is volatile? What if the contents of this page cache, everything will be gone, right? So in that case, what should do is Kafka sends the same data to a follower broker's RAM immediately. So Kafka not only does this, Kafka also does something else where there is a RAM which is exactly like this, and same messages will be sent here to this cache and to another space cache. That's how the replication is there, and RAM doesn't lose the data. So yeah, I think yeah, I think we're good. This is the reason why I like things to dig deep dive and explore, because now I know why Kafka is fast. Hardware wise, not entirely, but at least some aspects of why it's being fast. Even though the point is not Kafka being fast, there are many things that are fast. The reason is the specialty of Kafka is even though it's doing actions, seems like doing actions with disk, like in terms of storing the logs, but it isn't really is. If you see the flow, nowhere Kafka is interacting with the disk. So yeah, I think yeah I covered this, but let me save to disk. Haha, nice. Let me open this and see. Let me copy to. Okay, so I'm taking off. Let me click on replace my content one. What happens? So yeah, I think there are so many diagrams, but you can you can see that this is the correct diagram where I, or else I can write this. No need to. Uh, Kafka disk. Yeah, let's. Okay, why not normal? How we do it normal? Yeah, there's a Kafka disk, and yeah, I think I shared enough information by Kafka speed and some internal details. What is the duration? 33. Not good. This time bound thing is working for me. I actually put for half an hour. It's still 5 minutes. Nothing matters much. Yeah. The intention is at least not the intention actually. I was actually excited from 2 3 days to share this to someone because I get excitement and the only way to take that out is explain to somebody else, which I can do here very nicely. YouTube. Yeah, that's all for today's stream. I will meet you. Will the next stream will be sooner? I think in next week. Yeah, I'm stopping my stream. I'm ending the stream, guys. Thank you. Good night. Actually, good morning. Okay, since I copied, let me share this link. Ouch. Yeah, this is the link, and yeah, good night, everyone. Ending the stream. Bye.